I would like to welcome you all in the lecture series of control systems. In this session, I am going to discuss important questions from module 5. Mainly, I am focusing on the Nyquist plot. Also, the controller design, like the P controller, PA controller, PID controller. Okay, lead compensators also. Lag, lead. Okay, lead, lag. So first we'll see the theory questions. Later we'll move on to the numericals. So there are so many theory questions you can expect, like explain the Nyquist stability criteria. What do you mean by Nyquist plot? Why Nyquist plot is required? You might have heard about the M circle and N circle, right? M circle and N circle. So such kind of questions also you can expect. What do you mean by controllers? So what is the meaning of controllers? Why controllers are required? Okay, controller. It may ask for the 3 marks. Okay, 3 marks. Along with that, there will be another question. So you may get like a controllers, need for controllers. Explain proportional derivative and proportional integral derivative controllers with the second order system. Okay. So there are derivations you could try to follow up. Explain the principles of arguments in Nyquist stability criteria with the three statements you have to mention. Three statements with the equations. That is what expected. So these are the four important theory questions. So don't think that only problematic questions will be asked, but there are theory questions. There is no need to worry. Clearing the exam is not a big deal. So still, as you can see, there are so many type of theory questions you may get in the forthcoming examination. Explain the step-by-step procedure for designing the lead compensators. Similarly, explain the step-by-step procedure for using the lag compensator. This is university question. So that is what I highlighted. Next time you may get like explain the step-by-step procedure for designing the lead lag compensators. Similarly, sixth one, explain proportional integral controllers on second order system. Similarly, what is lag lead compensators? What is the meaning of lag lead compensators? So if you don't know the definition means you can draw the circuit at least. Draw the circuit diagram. Why can't you draw the circuit diagram? And why can't you draw the transfer function of that? Okay. Similarly, explain the procedure for designing the lag lead compensators. That's also an easy question only. Similarly, check the syllabus once again. State mapping theorem. In some syllabus of like a state university, I have seen like a mapping theorem. Okay, you please verify the latest syllabus mapping theorem. Okay. Similarly, some syllabus they mention about control theory. So some university, like as you can as you observe, there are control system and advanced control theory both are different. But some like university they have merged with the advanced control theory and control system both are clubbed together. So now we will see some numerical example. In the numerical example, you can see draw the polar plot. Okay, draw the polar plot with a suitable procedure and enumerate whether the system is stable or not. Then sketch the Nyquist plot for the system and comment the stability. Will it be stable or unstable or marginally stable? So you have to give the valuable comment and justify as well. You have to justify it. So another question is on Nyquist plot and ensure whether the system is stable or not. That you have to comment. Okay, that commenting also having the criteria. So for this, it's a state space. Consider the state space matrix. Okay. So what you can do is you have to model the state space modeling of this particular matrix you have to perform. Compute STM for the system for a given matrix. Okay. So you have to go for like a Laplace approach technique. So that you are supposed to follow. So thank you so much for watching this video. If you require Nyquist criteria, I can show you the Nyquist criteria. Okay, just for a while. So I'll be showing you at a glance of Nyquist plot. It is also known as polar plot, mainly used for determining the stability. The definition is already given. The Nyquist plot is a symmetric with respect to real axis. Actually, the Nyquist plot and polar plot are identical. There is no difference. Don't get confused about Nyquist and polar plot. It is used to draw the complete frequency response of an open loop transfer function. That is a specialty of Nyquist plot. So important terminology like a minimum phase system, non-minimum phase system, type, order, critical point. Critical point is one of the most important criteria for the Nyquist plot. Please note down critical point. Okay, this is one of your value point in the examination. What is critical point? Minus 1 plus 0j, this point is known as critical point. Critical point will always lies on the real axis. For a closed loop system to be stable, the Nyquist plot of G of S, H of S must be encircled to the point minus 1 plus 0j as many times as the number of poles G of S, H of S are within the right half of S plane. This is the stability criteria. You please note down this definition because most of the textbook you may get the similar kind of definition. So this criteria will be following the stability. Okay. What is encirclement? Number of encirclement is the difference between number of right-sided poles and number of right-sided zeros, P minus Z. That is called the encirclement. Stability using Nyquist plot. Okay, so these are the conditions. There are absolute stability. Absolute stability can be determined by using Nyquist plot. We can easily determine the number of roots locating at the right half of S plane. Okay, so encirclement area. Based upon the encirclement area, we are going to decide the stability, absolute stability. So Nyquist stability criteria. So n is equal to p minus z, where n is nothing but number of encirclement. You need to determine the number of encirclement. If there is no encirclement, then p must be 0 and the system is stable. No encirclement, that is one of the stability criteria. Case number 1. Case number 2, if n greater than 0, that is clockwise encirclement. Such cases, the system is unstable. N less than 0, then we call it as we can call p greater than z, then that is also a stable condition. So you can see like encirclement, see the direction, anti-clockwise encirclement, clockwise encirclement. Based on that, we can predict the stability. Clear? Yeah. So these are the different like encirclement. Kindly go through that. There are different type of shapes. Okay. So there is a numerical example. You can go through that. Draw the Nyquist plot for the system and identify the order of the system. First one. Next is actually calculation of magnitude and phase angle. Okay. Thereafter, formula is available to calculate the magnitude and to calculate the phase angle also. Similarly, see, you can draw the encirclement. Then you can predict whether the system is stable or not. Another example is also given. So based upon that, we can predict whether the system is stable or not. We can easily determine. Okay. So that's all. See, principle of argument also you can remember. What is principle of argument? You can go through that. If poles and zeros are enclosed by the random selected enclosed path in the S-plane, then the corresponding G of S, H of S plane is encircled by the origin P minus Z times, where N is nothing but P minus Z. Now, N is the number of encirclement. If the pole is enclosed, then there is a change in direction while mapping. If zero is enclosed, then there is no change in the direction of mapping. Okay. So there are some examples also. We can verify different cases. That's all. Okay. Then advantage, easy procedure and calculation. Most of the real-time systems experience a delay, and such system will be having a loop transfer function involving the exponential. Such system cannot be treated within the Routh-Harvey's criteria, root locus method, and etc. For such cases, we can use Nyquist plot. Then information on relative stability and absolute stability of the system easily obtained using Nyquist plot. In the root locus and all, there is no relative and absolute stability. You can clearly observe. Nyquist plot has wide frequency range of information, where Routh criteria and the root locus, which is having the limited frequency range of information. Nyquist criterion relates the stability of closed loop system to the open loop frequency response and open loop poles location. Application is mainly used for positioning, especially in the airplanes. Okay, these are the various applications. So let me know if you have any queries. We'll have discussion. Ultimately, thank you for watching this video. Kindly feel free to put the comments in the comment box. Surely I can revert. Okay, so kindly go through these questions before entering to the examination. So I prepared 5 modules important questions. All are equally important. Give focus on every questions and prepare very well for your examination. Wish you all the very best for your examination and happy